Assalamualaikum and hello everyone. Me and my roommates are from group 17. Today we are going to present about experiment 6 in CHM260, which is about high performance liquid chromatography HPLC. This group is consists of 4 members. Firstly, me myself, Muhammad Azamuddin bin Tua, and then Ainurim Syafiq bin Mazrul Nisha. Third, Muhammad Nazirul bin Ramli, and lastly, Hafiz Faris bin Alanyu. HPLC is an analytical chemistry technique used to separate, identify and quantify semi, also non-volatile compounds in liquid samples. Retention time is the quantity of time that a compound takes up on the column after it has been injected. They are usually recorded in minutes or seconds. Chromatographic peaks can be elected by individual components eluting from column over time. Good peak shape can be interpreted as a symmetrical or Gaussian peak, and poor peak shape can be include both peak fronting and tailing. In this experiment, we are aiming to achieve 3 objectives. Firstly is to determine the retention time of a standard solution, which is caffeine. Second is to identify the caffeine peak in a soft drink sample. And lastly, to determine the amount of caffeine in a soft drink sample using the response factor method.
Hello, my name is Hafiz Faris bin Alanyu, and I will be presenting the methodology for high performance liquid chromatography HPLC. And as we all can see, this is the block diagram for HPLC. There is 5 major components in HPLC, and this is the first one, which is mobile phase. It is a reservoir and filtering. The common type of reservoir is a glass bottle with special saps, Teflon tubing and filters to connect the pump inlet and to the purge gas helium used to remove gases. The condition is readily available in pure form. It is low viscosity, compatibility with the detection method, able to dissolve the sample components, and no chemical reaction with the components. Next is the pump and injectors. The function of the pump is to force the mobile phase to flow through the packing, deliver mobile phase through the system, and lastly install in order to maintain stable flow to avoid pulsation. The 3 types of pumps is reciprocating pumps, displacement pumps, and pneumatic pumps. For the injectors, the function is put sample in the mobile phase. The syringe injection through a self-sealing elastomic septum. It is the earliest and simple means of sample intro. There is also micro syringes designed to withstand pressure up to 1500 psi IUs. And lastly, the sampling loop. It is the mostly wide used method. Normal sample size is 5 to 500 microliter, and the permit intro at pressure up to 7000 psi.
For next slide, we are going to talk about the column. The column are divided by 2, the analytical column and the guard column. The analytical column is a straight stainless steel calibrated tube. The column length for the analytical column is 10 to 30 cm. The column ID is 4 to 10 mm. Column packing particle size is 5 to 10 microcentimeter. And the guard column is the composition is packing closely similar to analytical. The length column for the guard column is 2 to 10 cm. The particle size are larger to minimize the pressure drop. The function of the guard column is to increase the lifetime of an analytical column, prevents the deactivation of the analytical column by absorption, and the last one to prevent clogging while extending its lifetime. For the last slide of the methodology is detectors. Detectors also divided by 2, the bulk property detectors and solute property detectors. For the bulk property detectors, it responds to mobile phase bulk property. It is used to refractive index, dielectric constant, or density. It is modulated by presence of solutes, and solute property detectors is respond to some property of solutes. It is used for UV absorbance, fluorescence, or diffusion current. It does not processed by the mobile phase.
Hello, without further ado, I will explain this result. This is the first result. As you all can see, it is a standard caffeine, and based on the graph, there is only one slope. After that, we can refer the data given under the graph shows the rate is 100%, which means it is pure caffeine. But the main calculation here is for response factor, and the formula is area of standard peak over concentration of standard mgml. And based on the data given under the graph, the area of standard peak is 6,249.48779, and the concentration of standard mgml is given in the lab manual, which is 0.1, and using the formula we get 62,494.88 mgml for the response factor.
For the next slide of the result, we are going to calculate the concentration caffeine in Coca-Cola. We will use the peak area divided by RF to calculate the concentration. 1 milligram per milliliter is equal to 1000 ppm. From the graph that we obtained, peak area for concentration caffeine is 7001.12365, and for the RF, we already calculate from the previous slide, is 62494.88. 7001.12365 will be divided by 62494.88 and will get the 0.112 milligram per milliliter. 0.112 will multiply with 1000 to get the 112 ppm. And the last result is to calculate the concentration of caffeine in Levita. We will use the same formula as the Coca-Cola, the peak area divided by RF. The peak area for the Levita is 3.481617 10 to the power of 4, and the RF, we use the same RF, 62494.88. 3.481617 10 to the power of 4 will divided by 62494.88. We'll get the 0.558 milligram per milliliter. 0.558 milligram per milliliter will multiply with 1000 to get the 558 ppm. And the last one, we'll calculate the average concentration. We use the Coca-Cola concentration plus Levita concentration and divided by 2. For the Coca-Cola concentration is 112 ppm and the Levita concentration is 558 ppm. 112 ppm plus 558 ppm will divide it by 2 and we will get the average concentration caffeine is 335 ppm.
Next, we move to the discussion part. The first one is retention time of standard caffeine solution. In order to identify caffeine in soft drink samples, the Hplc analysis properly determines the retention time for the standard caffeine solution. The validity of the experimental method is determined by the reliable and precise detection of caffeine peaks in the sample, which is ensured by this constant retention time. The second one is caffeine peak identification in soft drink samples. By comparing their retention times with those of the standard caffeine solution, the caffeine peaks in Levita and Coca-Cola were found. This shows that caffeine is present in both soft drink samples and that the Hplc approach succeeds well for analyzing caffeine in complex matrix like soft drinks. The third one is response factor or RF and quantification. The caffeine content in the soft drink sample were measured using the response factor RF equal to 62,494.88 mg per ml that was computed from the standard caffeine solution. The response factor made it possible to determine the caffeine concentration precisely, which ensured reliable and constant quantification result. Next, we move to the caffeine concentration in soft drink. Coca-Cola contain a caffeine content of 112 ppm, while Levita contain 558 ppm. The significant difference in caffeine concentration between the two soft drinks show that various brands contain different levels of caffeine, possibly due to the product formulation or marketing strategies. The next one is average caffeine concentration. The two soft drink samples have an average caffeine content of 335 ppm. This value helps to determine the average amount of caffeine in soft drink, which is crucial for figuring out how much caffeine is consumed through diet. The last one is comparison with regulatory limit. Although this study observed average concentration of about 335 ppm, the amount of caffeine in soft drinks can vary greatly. Therefore, it will be helpful to compare these values to recommendation for daily caffeine intake or regulatory guidelines.
In conclusion, the experiment successfully achieved its objective using high-performance liquid chromatography to analyze caffeine in a soft drink sample. The retention time for the caffeine standard solution was determined, allowing for the identification of the caffeine peak in the sample. Also, other than using high-performance liquid chromatography, we can use other alternatives such as Fourier transform infrared spectroscopy (FTIR) and gas chromatography (GC). By applying the response factor method, the concentration of caffeine in the soft drink was quantified. This experiment demonstrated the effectiveness of Hplc in both identifying and measuring caffeine levels in complex mixture, highlighting its utility in analytical chemistry. That's all from us. Thank you.